Welcome students. So today we are going to start our first unit, digital control system. First, let's see what are the contents of this particular unit. First, we'll discuss the introduction about the basic concepts about the digital control system. Then the configuration for the basic digital control system, its advantages, disadvantages. Then we get into some details about the data conversion, quantization, sampling, reconstruction, sampling theorem, practical aspects of what to choose as the sampling rate, then zero order hold, its transfer function, basic concepts, and transfer function of first order hold as well. First, let's get idea about the digital control system. Okay. Up till now, whatever the in the control system one, the kind of control systems we have seen were the time-based control systems, and those were continuous in nature. Correct. Those were the continuous in nature. Okay. Those we also called as the analog controller. Those we also called as the analog. But as the demand for the more flexibility, more adaptability, optimality has increased, and because of that, the system becomes more and more complex. The system has become more and more complex, and that has results in the severe increase in the economic control complexity as well. Because for the analog controller, the modifications to do the modifications are somewhat very difficult. Okay. So that increases the complexity, not just in the case of the circuits or the tools, but also in the economic control complexity. So the analog, so in the recent decades, you can see that the analog controllers are now being replaced by digital controllers, by digital controllers, and first inputs and outputs are defined are type of discrete time instances. Discrete time instances. We are going to see how can we say it is the discrete time instances. Okay. And digital controllers can be found in the form of digital circuits, digital computers, microprocessors, microcomputers, okay, like that. We will see the basic configuration for the control system. Okay. A typical continuous time control system, okay, this basic configuration that we have already seen. Okay. Here you will see, this is the plant. This is actually a system. Okay. This is actually a system of which, okay, system can be for any multiple number of inputs and number of outputs can be there. So here in this case, we for the analog control system, we have seen the systems for the single input, single output. So we are only talking about the one part, one specific part of this plant. Okay. So it is starts with the command input. Okay. This is the controller which takes the error as the input and gives the control input. Gives the control input to the plant, to the plant. And according to this particular control input, the plant behaves and gives the output. Okay, and this particular output again checked or written back through the help of sensors, okay, the feedback sensors, and it's compared with the command input. So that's why this command input is often called as the ideal output. The ideal output, and this is your actual output. So whatever the difference between these two is what we call the error. And according to that error, the controller takes the decision how the plant's input to be changed or modified. And for the modified input, the plant output will change. So this is our typical continuous time domain system, analog system. Okay. Now for the this digital control system, you will see here. The major things are, see, the plant is there as it is, command input is there, or the ideal output is there, correct? Sensors are there, output is there. this computer or the controller is there. What are introduced here is the analog to digital and digital to analog. Okay, these are the two converters that we have introduced. Why we have introduced? Because this controller is running on the digital data. It only senses the digital data. It only considers the digital data. It runs on the discrete data. That's why these analog signals are to be converted into first digital signals so that the computer will learn what the input is and accordingly it will decide what the output should be, and this output again will be digital, correct? So it takes the input as the digital signal, it gives the output as the digital signal, but the digital signal may not be understood by the plant, so it again has to be converted back into the analog form. Okay, so that's why the digital to analog converter is after the controller, and the analog input is now given to the plant. The configuration is same as that of the continuous system, but the difference is introduction of the discrete converters. Okay, from analog to digital and digital to analog, because digital control systems, the controllers are digital. Okay, they understand the discrete data, not the continuous data. So to communicate with this plant or the system, they need to understand what is these signals are, correct? So the signals are analog in nature, but controller cannot understand the analog signals, so it has to be converted from analog to digital so that the computer will understand the system. Okay, and the computer will generate the digital output, so digital cannot be understood by the plant, so digital to analog controller will give us the analog signal which plant can understand and consider as the valid input. So the basic configurations are the same. Okay. So now we'll discuss about the advantages. So the digital components are less susceptible to aging and environmental variations. They are less sensitive to noise and disturbance. Digital processes are more compact and lightweight and can be made very versatile and powerful for control applications. So if you look at the different applications, so recently whatever kind of digital electronics you are using, they are all, or any electronics equipments or appliances that you are using, these are all digital. These are all running on the discrete data. Okay, and you can see how compact they are, how lightweight they are, how powerful they are, how versatile they are, how they're, though they are being very complex in nature, but their use is very, easy to use. Okay, the cost of the old, the cost of microprocessors or the DSPs are continuously going down. Okay, and they offer more flexibility in programming. The algorithm can be changed at any time. Correct. We can use the same microprocessor for the different purposes. Just the algorithm need to change. Correct. So they offer more reliability. They provide improved sensitivity to parameter variations as well. It also comes up with the limitations. Okay. See, we are talking about the digital data, digital processors, correct? So we need to have the proper computing scale, speeds, correct? So the limitations comes with the computation speed and the signal resolution, because the finite word length of the digital processor, correct? It has the limitations. Okay, it has the specific way word length, that means the how much bit data it can understand or it can process at one single time. But if you compare with the analog controllers, even in there in the real time, the resolution theoretically is infinite. Correct. For the analog controllers, the resolution or the word length itself is infinite. So the finite word length of the digital processor often translate into the system's instability. But if you look at the processors, specifications, you must have seen there is this 8-bit processor, 16-bit processor, 32-bit processor, 64-bit processor, and likewise. Okay? So these are the different word lengths of the processor. So that increases its flexibility as the word length increases. You cannot run any different application of 32-bit on the 8-bit processor, correct? That makes it unstable. Okay, so that may result into the limit cycles. Limit cycle is kind of the this instability. Limitations on the computing speed also causes the time delays. Okay, also causes the time delays. So that may again result into the instability. Okay, these are few of the advantages and disadvantages. Advantages: digital control system improve sensitivity. Use the digital computers, the algorithms can be easily modified. Disadvantages: develop the complex mathematical algorithm. Okay. The algorithm can be modified, but as the application changes, you need to use the different logic every time. It also loses information during the conversion due to technical problems. Also, you can say the conversion. Like if when you are considering this infinite data to be converted into the finite data, correct? Somewhere we are going to lose the information because most of the signals are continuous in nature. Okay. Analog signal takes any value over the continuous range, and digital signals can only take the finite values that given in the discrete. So continuous time signal is like this. Okay. Over continuous time, at any time you will always get this particular value. Correct. You'll always get the value for the magnitude. But in the discrete signal, you'll see for the any time on the time axis, you will see the signal's magnitude is only available when at certain time instances, not at all the time instances. So if you see, if this is 0 and this is 10, 20, 30, 40 seconds, okay, so you will see from 1 to 10 or 0 to 10, in between that, you will not get any value for magnitude. It will be 0, it will be 0, it will be 0. But at this particular time instant, you will have this magnitude. At this particular time instant, you will have this magnitude, and likewise. So you can see if we compare this to this holds the infinite data and this holds the finite data, then you can see some of the information is being lost. Okay, so here we'll conclude our today's lecture. Thank you so much, everyone. In the next lecture, we'll continue the